Greetings and welcome to the presentation. The topic is using linear regression to predict outcome of a black box machine learning algorithm. The work is done by Soumitra, Mittal, and myself, Pritesh. Machine learning algorithms are used everywhere. Search engines use them to rank web search results. E-commerce sites such as Amazon use them for product recommendations. Many businesses rely on these platforms for their operations. Machine learning algorithms used in these services are like black boxes to us. We don't know the internals of these algorithms. We wanted to find out the feasibility of using machine learning itself to decode or predict outcomes of these algorithms so that the businesses can make better decisions. We will be predicting the valence of a song on Spotify. The value of valence is calculated using machine learning algorithm, which is a black box to us. The value of valence lies between 0 to 1 and describes the positivity of a music or a soundtrack. Closer to 0, music sounds sad or depressed. Closer to 1, music sounds cheerful. It plays a vital role in auto playlists and music discoverability. Therefore, artists and label companies can use it to improve tracks' visibility. Our methodology was based on KDD process. We iteratively improved our model by performing data transformations and feature selection till we had the most improved model. After the pre-processing of the data was done, the first challenge was to fit in categorical features. Genre, key, mode, and time signature were the categorical features. We applied dummy variables or one-hot encoding to these features, increasing them from 15 to 51. We got R-squared value of 0.48. There is a weak relationship here. However, 51 features increased the complexity and we suspected that it also degraded the performance of the model. So we came up with a better solution to feature engineer the categorical features. We gave a rank or a weight to each unique value in each category based on the average valence for that specific value. For example, there are 26 unique values in genre. Reggae had the highest average valence score, hence was given the highest rank of 26. The ranks were also scaled using max absolute scalar, scaling the value in the range of 0 to 1 without changing the sparsity of data. We then applied linear regression on the transformed features. We got the R-squared value of 0.63 on 15 features. The model has an improved value of R-squared as well as has a fewer number of features. It gives credibility to our approach towards the categorical data, but there still existed the strong possibility of multicollinearity in our system. To reduce multicollinearity and improve the model further, we did feature selection. We first plotted Pearson correlation metrics to flag the correlated features. We also plotted VIF as further validation of existence of multicollinearity. We then plotted distribution and box plots of flagged features to identify the most problematic ones, the ones with large number of outliers. Based on this information, we proceeded with bidirectional elimination and tried multiple combinations of features to select the final ones. Here are the VIF charts before and after feature selection. And this is the final model's result. Although R-squared value decreased slightly from the last model, but we did reduce the number of features, reducing the complexity and also minimize the cost function. Here we can see the distribution of residuals on the right side and on the left side, a graph to check the homoscedasticity. Our residuals are in normal distribution, but the homoscedasticity is not very clear. We can see the bias in the model, potentially due to missed features. It's possible that Spotify used more features of the track that are unknown to us. However, we did manage to achieve fair level of accuracy. Now, in our case, we had the data and knew the variables that impacted the value we were trying to predict. But in most cases where we want to predict outcomes of a more complicated product such as search engines, we won't really have the data. It would be incredibly hard to scrap data and identify the variables or the combination of variables that affect the outcome. Furthermore, one slight change to the algorithm we are trying to mimic could break our model completely and may again require work from the ground up. To overcome these problems, we could use machine learning itself to scrap and identify the data intelligently and use domain expertise to make better models. That's it from the presentation. Thank you for watching.